Section 7.2 covers the applications of a normal probability distribution, and in the slides there are detailed notes about what you do to solve these different kinds of problems. And I'm going to go right to one of the examples, 7.2 number 40. Fast food restaurants spend quite a bit of time studying the amount of time cars spend in their drive-thrus. The faster the cars get through the drive-thru, the more opportunity there is for making money. QSR magazine studied drive-thru times for fast food restaurants and found that Wendy's had the best time, with the mean time spent in the drive-thru of 138.5 seconds. Assuming drive-thru times are normally distributed with the standard deviation of 29 seconds, answer the following. Part A, what is the probability that a randomly selected car will get through Wendy's drive-thru in less than 100 seconds? It'll be good to note that in the description, they mention that the wait times are normally distributed. And when you see something that's normally distributed, and when you're trying to find the probability of something that's normally distributed, you'll use these particular methods of section 7.2. We're trying to find the probability that x is less than 100. And there are different ways of finding that probability. One way is to use a formula. The formula for a normal probability distribution is this formula. But I mentioned earlier that this formula is a little bit cumbersome to use, and we won't really focus on using it in this course. In fact, if we were to try to use this formula, to get the probability, it would need to be put into an integral, and we'd have to evaluate that integral, which takes some calculus. And even using calculus, this integral can be pretty cumbersome to evaluate by hand. So the best thing is instead to either use technology like a calculator or use a table. We'll take a look at this second method, using a calculator. When you use a calculator, you'll use either NCD, which is on the Casio calculator, or you'll use the function called normal CDF on the TI-83 or 84. And there's a couple things to note. One is that you will not use NPD or normal PDF. Instead, you're only going to be using NCD and normal CDF. A second thing to note is that when using these functions, sometimes you'll have to put negative infinity into one of the sections of the function. And when you want to type negative infinity into the calculator, one way is to type negative 10 to the 99 power. And so you would type it in this way. You do that when the probability is for something that's less than. If you ever have to type positive infinity, then it's kind of similar. You still have to type 10 to the 99 power. That comes up when it's asking for a probability of more than. One last note is that when you're using a calculator, if you want to type a negative number, make sure to use the negative sign button on the calculator. Not the minus sign, but the negative sign. For this first problem, it would be helpful to draw a normal curve The mean of this normal curve is 138.5. The standard deviation was 29. Just go like that. Standard deviation was 29. The problem is asking what's the probability that a car would wait for less than 100 seconds. So if this is 138.5, the x-axis is increasing on this side and decreasing on this side. So 100 is going to be somewhere on this side, somewhere down here. I'll just guess and I'll put it about here. So here's 100. And we're trying to find the probability that a car would wait for less than 100 seconds. So that would be represented by the area of the curve that's below 100. Here are the steps that you would take on the calculators, on the Casio, the TI-3884. On the Casio calculator, so ultimately you'll choose NCD as your function, and when you choose it, it'll ask for the lower bound, the upper bound, the standard deviation, and the mean. The lower bound is negative infinity because the shaded part of this curve just goes forever towards negative infinity. There's no end to it. The upper bound is 100 because that's where it stops. And it's similar when you do the TI-83 and 84, you'll choose normal CDF for your function, and it'll ask you for the lower bound, upper bound, mean, and standard deviation. And again, for the lower bound, you'll put negative infinity, or in this case, negative 10 to the 99 power. And when you work that out, your result should be about 0.0922. So another way to solve this problem is to use a table. If you're doing it this way, it still helps to draw out that normal curve. I'm going to draw it one more time. Around there for anything less than 100, so I'll shade it on that side. And when you use a table, the table is the normal probability table. That table is available on our course site on Canvas. If you go to the modules, when it starts talking about Chapter 7, there's the normal probability table. This is what it looks like. This table is what they call the standard normal distribution table. And that means that all of its values are based on z-scores. So before using the table, we'll have to find the z-score for x being 100. So here's the formula for the z-score. X is 100 because that's our upper bound. Here's the mean and the standard deviation. Plug those in. The z-score comes out to negative 1.33. And when you do that, you're not changing the value of your probability. The probability that x is less than 100 is equivalent to the probability that z is less than negative 1.33. All that you're doing when you find the z-score is you're just converting it so that it's not in terms of x, but instead it's just all in terms of z. Now that we have negative 1.33, we can go to the table. And in the table, we'll look for the z-score. All of these values in the middle represent the area under the curve to the left. And there's a picture to represent that. For any z-score that you use, the number in the middle, let's say this one right here, 0.0059, that would represent the actual area under the curve to the left of that z-score. Our z-score is negative 1.33, so we'll go down. Here's negative 1.3, and then the second decimal place is up here. We want it to also be 3. So negative 1.33, look where they line up. It looks like they line up right here. .0918. That just means that at a z-score of negative 1.33, if this right here, if this z-score was negative 1.33, that area to the left is 0.0918. And that's what we were looking for. Our probability that x is less than 100 is equivalent to the probability that z is less than negative 1.33, and according to the table, that value is 0.0918. You might notice that in the last result that we got using the calculator, it came out to be different than this result here. Last time we got 0.0922. In this result, it came out to 0.0918. And that's okay. It's okay that there's a slight difference. That difference is because when you use z-scores in the table, you have to do some rounding off, and that rounding off leads to slightly different results. In the next video, we'll talk about Part B.